Hello, good afternoon, everyone. My name is Donal McNamee. I'm the Managing Director of Roadmaster. We're a manufacturer of spray injection patching machines based in the Republic of Ireland. And what I want to talk to you today about is a study that was done, or a case study that was done in a local authority in the Republic of Ireland, where they compared traditional road repair methods against that of spray injection patching. And what they done was looked at the cost benefits and the carbon benefits of one against the other. And the results are quite striking and surprising. First of all, what the council noted was a 50% reduction in their carbon footprint simply by using spray injection patching against a direct labour crew. They also achieved 58% cost savings, and they were able to almost triple their productivity compared to the direct labour crews that were operating during the trial. Now, these are quite striking figures, so I think it's worth some time to delve into them. But just before we do, we'll talk a little bit about the case study and where it was carried out. So the case study was carried out in County Meath, which is in the east of Ireland. It's the 14th largest county on the island of Ireland, the 8th largest in terms of population. There's a total road network of just over 3,500 kilometres, of which 3,400 kilometres of secondary, tertiary roads. So that's the sort of road on which the trial was conducted. 4 of the 6 national primary routes from Dublin passed through or close by County Meath. That's those highlighted in yellow. That places heavy traffic on the surrounding network, and you also get this huge tidal effect in the mornings and the evenings of commuter traffic passing through Meath, and that places pressure on the secondary and tertiary roads as well as the primary network passing through it. But County Meath has another couple of features, shall we say, that were quite important in the trial. The topology of County Meath is quite different from that of the rest of the country. So running through the northern part of Ireland, you've got a heavy glacial till mix, which is a mix of clay, sand and gravel. And this type of material is very, very prone to waterlogging. And waterlogging can be a huge issue in County Meath, County Cavan, and running on that strip across east to west Ireland. The other thing with Meath is that it's blessed with really high quality agricultural farmland. So you've got a lot of intensive dairy farming, grain farming, sugar beet, and things like that. But again, that's putting a significant pressure on a secondary and tertiary road network that was never designed to carry machines such as that in the photo. And again, that placed a significant pressure on the road network that the engineers there were dealing with. So the challenge that Meath faced. The trial itself took place in one of 6 of the municipal district areas in County Meath of Ashbourne. Ashbourne is approximately 400 kilometres of national road or secondary road, and it's a significant commuter route. As you can see there, it's highlighted in black, so it's sandwiched right between the main county of Meath and Dublin, so it's got quite a heavy tidal flow of commuter traffic passing through it every day. The other significant challenge within the whole of Ireland, and indeed here in the UK, has been the rainfall and the increase in rainfall over the last number of years. In fact, 2003 was well above the average rainfall, and it was the wettest year on record as reported by Met Éireann since they started records back in 1946. The cumulative rainfall figure for 2024 was once again well above national average. And when we talk about percentages well above, we're not talking about 20%. You can see here the month of March, for example, rainfall was 185% above national average, 201% in July back in 2003. So this is a significant change that the council is having to deal with in terms of maintaining the road asset in rainfall alone. Again, looking at the challenge, the area of district of Ashbourne records their number of pothole complaints. So in Ashbourne alone, in 2022, they just received 143 pothole complaints. That figure increased from 2023 up to 322. And by the time the report was conducted, which was April 2024, the pothole count there was 191. But if we extrapolate that out to the end of the year, they were looking at a pothole count approaching somewhere 573, 580 potholes. So what's important isn't the number of potholes that were being recorded. What was important was the trend. And it was quite clear to the engineers and me that this problem was getting away from them. They were dealing with a road network that was suffering from heavy traffic, heavy commuter traffic, heavy agricultural traffic, and increasing rainfall. And they were finding it more and more difficult to get on top of the problem of maintaining their essential infrastructure and asset. So what did they do to do this? They were looking at new and innovative processes to see how they got to get on top of this problem. Process that they elected to look at was that of spray injection patching process. A lot of you in the room will already know what it is, but for those that don't, spray injection patching is a fast and cost-effective method for repairing potholes, cracks, and other road surface defects. There's a number of machinery manufacturers out there that apply the same process, and what I'm talking about today is not the machine, but it is the process and how it can be used not only for repairing roads, but especially when it comes to the whole area of preventative maintenance, which I think is something that's hugely important. The spray injection patching process itself is a six-step process. First of all, you'll position the machine over your repair area. You will use high volume air to blow out the repair, blow out any dust or debris from the repair area. You will then put down a thin layer of tack coat to seal up the road surface area that you're about to repair. The next step is applying a mix of 2 to 6 millimeter aggregate coated in a 60% cationic bitumen emulsion. And on most machines, this is a calibrated mixture to make sure that what's going down into the ground is going to stay down on the ground. You'll finally dust it off with a light layer of dry aggregate that'll allow the machine or allow the patch to be trafficked immediately. And after that, you roll in your patch and you move on to your next patch. So it's a very, very quick, effective process. A typical patch will take no longer than 3 minutes. And there's no waste produced at all. You just go in, you seal up your road, apply your patch, and you move on to the next. The process that they were comparing against in the trial, the typical method for road repair in County Meath consisted of a direct labour crew, which consisted of a four-man crew. They had a 7.5 ton pickup. They had a tractor and a trailer mounted bitumen lance and aggregate for the carrying out the repairs, and a plate compactor for sealing in the repair once it was complete. In terms of materials, they were using a delay set asphalt for the majority of the repairs, over which they would then use the aggregate and bitumen emulsion to seal it up. And in certain cases, they also carried a base course of 804, which is an unusual thing to carry, but you have to remember, like I said before, in County Meath, that they have that typical soil composition that means that when they got a pothole, it generally tended to be a very deep pothole because it really started to pull up the base course from underneath, and they had to reconstruct that. The spray patching unit that was used as part of the trial was a Roadmaster SIP unit, an 18-ton unit with a 1,000 litre bitumen emulsion tank and a 5 cubic metre hopper, and a single trained operative manning the operation. So a little bit on the trial itself. The trial was conducted over 5 days from the 23rd to the 29th of April. It was conducted solely by the engineers and Meath County Council, specifically the district engineer in Ashburn. It was a side-by-side trial, and that's to say that the direct labour crew were working on the very same dates as the spray injection patching team, and that meant that there was no variability for weather or commuter traffic flows or what have you. So it was a like for like comparison. In terms of what was measured, we were measuring the fuel. They measured the material usage for both processes, and they also measured time. This is the labour that was into the spray patching process, and also the time that went into the four-man direct labour crew. The headline figures from it was that the direct labour crew, during the duration of the trial, output 9.25 tons of material, compared to the spray injection patching output, which put out just over 24 tons of material. And that becomes important later on when we look at the exact figures. Interestingly enough, the trial findings came up with a couple of areas that they discovered themselves where they could use the spray injection patching process quite effectively and where they couldn't use the direct labour crew to address. The report stated that they were able to use the spray injection patching machine to seal up areas of road that were displaying early pothole forming and alligator cracking, as you can see in the picture. And they were also able to provide an overlay of aggregate to areas that would likely fail and form potholes in the winter. And again, this is going back to the whole notion of preventative maintenance. If you can get in there and seal up that sort of defect before the water gets in and before your pothole develops, you're winning. and you will never be a cheaper time to do it than when it's at that stage. So prevention is definitely the way forward when it comes to maintaining the secondary and tertiary road networks with this process. They also found that the spray injection patcher was effective at areas of the road typically 20 meters by 5 meters that were too small for including in an annual roads works program. So these were areas that weren't just typically potholes, such as the condition of this road here, which, to be honest, was let get way too far. But it wasn't included in the annual surface dressing program because it was deemed too small and too insignificant. So the spray patcher was able to address those issues between doing complete road surfacing and just going out repairing potholes. So it was able to get that gap in between the two and allow a very, very effective use of the process and of their budgets. Again, the trial findings found in favour of safety of one process over the other. The 4-man crew consisted of 4 guys working on the carriageway, whereas the spray patcher had just one operator in the cab. Also, from the amount of plant that was involved, the spray patcher, of course, was just one machine, whereas there was a 7-ton pickup and a tractor and trailer and a plate compactor involved in the other operation. So there was a lot of moving parts in it. In terms of the carbon findings, and this is where it really gets interesting, both processes were measured across the carbon life stages between A4 and A5, which are the construction phase and the transport phase. I won't say we discounted the phases from cradle to gate because they were the same for both processes. So we just measured what was going to be different in it. They measured what was going to be different in it. And the methodology that was used to calculate the carbon footprint is that was come up by the RSTA back in 2023. And although the RSTA have since launched their new carbon figures, the methodology largely remains the same. And that was the methodology that was in place when the trial was conducted. But the major findings from the carbon report, when you crunched all the figures, was that the direct labour crew was typically generating 3.19 or almost 3.2 kilos of carbon per metre squared. That was compared to the spray patcher, which was costing 1.6 kilos per metre squared, almost exactly half. And that's where the 50% figure comes from. And when you think about it, and this is going back to the productivity figure, while the carbon footprint per metre squared by the spray injection patcher is able to output almost 2.6 times more material than the direct labour crew, that directly feeds into more bang for your buck when it comes from the carbon point of view, and that's how it's able to come up with that amazing figure. Coupled with that is the cost reduction of one compared with the other. The SIP delivered a massive 58% cost saving on the 4-man crew, and there was a couple of factors into that. Again, mostly down to the amount of material that the single operator could deliver in the spray injection patcher compared to the 9.25 tons of the direct labour. Again, it was almost 2.6 times more. In terms of fuel consumption, the spray patcher was coming in with a little bit less than the direct labour crew, but again, it's significantly less man hours and man time. But when you put all those into the calculation and you measure it down, it was 443 euros per tonne for the direct labour compared to 305 euros per tonne for the spray patcher. So again, a massive difference in terms of cost when you factor everything into it. So in summary, folks, during the trial, what Meath County Council found was a massive carbon saving, a reduction in carbon emissions of up to 50% by using spray patching, a 58% cost reduction. They were able to triple their output, or almost triple their output with the spray patcher compared to the traditional method. And that, believe it or not, was the thing that really swung it for them, because as you've seen at the beginning, the pothole count was getting away from them, and they would have had to deploy an awful lot of resources just to pull that curve back in to stay on track. But now they were able to output 3 times, or almost 3 times, the same amount of material in the same length of time. So for the first time, they could see an opportunity to actually get ahead of the pothole problem itself, and also to use the spray patcher to address those surface defects that hadn't yet become potholes but were destined to become. Otherwise, they were going to be playing whack-a-mole and spending a lot of money and never getting ahead of the problem. But one of the other major aspects of it was they were able to free up operators to look at other, and I would argue, more important things. one guy on the spray injection patcher frees up 3 other operatives for other essential work on the road network. And from my point of view, the essential work of the road network is that of drainage. We were all here today and we're talking about preventative road maintenance and preventative methods of repairing roads. To me, the single most important thing an asset manager can look at on their road network is drainage. Keep the water off the road. And if the water is kept off the road will last, and you will stop that deterioration and the alligator cracks, and the road starts to deform. So again, this whole process has allowed me to use more resources more effectively to get ahead of the problem and ultimately get their pothole count down. So thank you very much for your time, folks, and thank you.